Welcome,
Namaskar, sir.
sir.
Good
Good evening,
evening,
sir.
sir.
Namaskar.
Ajay, sir.
Good evening. Welcome to all participants. Good evening to all.
Good evening, sir. Good evening, ma'am.
Good evening, ma'am. Ajay, sir, shall we start?
Yes, ma'am. Please start. Thank you.
Okay, sir. Good evening to all the participants and the subject experts. I, R. Renuka, Vice President, Research and Innovation Wing, Telangana Chapter, welcome you all to the day 4 of a step-by-step guide to write a good research paper organized by Research Foundation of India in association with Faculty of Commerce, Parul University. Sponsored by World Conference Forum, JHERF, World Federation of Science and Technology, International Research Guide Federation, Academic Research Guide Association, Edu Academia, and many other organizations. Today we have an eminent subject expert in the field of data analysis, Dr. Ravi Vyas, sir. I welcome you, sir. It's my honor to present the profile of Dr. Ravi Vyas. Dr. Ravi Vyas has an extended experience of more than 15 years in academics and other related work. Currently, sir is Associate Professor at Department of Commerce at St. Paul Institute of Professional Studies, Indore. He is a stout motivator and used to work on own initiative and inspired the fellow co-workers towards the research-related activities since last years. He is also keenly involved in organizational management to policy making for proper molding of students in terms of teaching them the values and to help students to achieve high improvements in their academics. He also attended many national and international conferences, workshops, faculty development programs. He has written more than 37 research papers, and those were published in journals of repute. He is working as a research guide in Commerce Department in Devi Ahalya Vishwavidyalaya, Indore. Sir is currently working as a reviewer for research papers in various journals. Sir is also working as chief editor for Luminous Research Journal. Sir also served as a keynote speaker and research person at many workshops on research methodology and ICT-enabled tools. Sir has been awarded the Best Paper Presenter Award many times. Dr. Ravi Vyas also working as convener of Research Forum at SPIPS Indore. Sir co-authored and authored a book on financial accounting. Sir has been awarded with various international awards. Some of them are International Award for Professors in Excellence in Teaching in Higher Education. Sir is also a member of Indian Red Cross Society and also a member of State Press Club. Sir, thank you for a very good profile. Thank you so much, and you can take over the session, sir. Thank you.
Thank you, first of all, Renuka ma'am,
Thank you, sir.
for giving so much weightage to me because I'm not that much person of a caliber. But then too, you have given a weightage to person like me. That is something, a matter of humility. I wanted to show you. Secondly, I wanted to thank Team RFI, Ajay sir. It has always been it's always been a matter of happiness that whenever sir calls me to have a session, so happily I accept because it is just like a family. We are discussing all these things, and it is my, I can say, a moment of happiness for me also to whatever small knowledge I am having, I'm possessing, just to share with the group of some intellects here. So thank you everyone for inviting me to this session. Now I'll be starting with the session and saying that today we'll be having a session on how we can easily use MS Excel for data analysis. Friends, you know that there are many softwares available for statistical analysis. You know already them. But it is always a confusion regarding how to use those softwares. The reports they use to generate is somehow very confusing. And many times we cannot be able to get the clear, we can say, the picture, how to interpret the data, how to interpret the result. So here I feel that MS Excel is one of the very easiest, we can say, a source through which we can get all type of data analysis. If you want to have a particular set of analysis on your research paper, or can say on your thesis, it is very easy to generate, and it is very easy indeed to interpret the same. So begin with the thing. Let me share the screen. I hope the screen is visible to everyone.
Yes, sir, visible.
Yes, thank you so much.
Yes, sir.
Thank you so much. So this is
sir.
GG. So this is our agenda for today. That means we have 7 points to discuss in this session. First of all, we'll be starting with how to activate data analysis tool pack in your Excel. Secondly, we'll study about how to get the normality of the data, the normal curve, bell-shaped curve, we can say. Third, we'll know about ANOVA with a single factor. Then we'll discuss about TTest. Further, we'll discuss about ANOVA for uneven sample size. Then we have ANOVA for even sample size. And lastly, we'll discuss about regression analysis for simple regression. So this is our agenda for today's presentation. So starting with the thing, now every one of you will be having MS Excel already in your systems. Okay. Now it is just to activate the data analysis toolkit. How to do that? Now see, open an Excel sheet in your PCs or laptops, and then go to the left top corner where you can see file here, a ribbon which has a file name here. Click on that. Then a window will open to you. In that window, you have to go in the last item. So here in the last, we can see options are given. So click on that options. When you click on options, a dialog bar will open to you. Again, it will ask about something. Then here again, we have to go in the left side of the bar, and then you can find it, the second last item. The second last item is name as add-ins. So click on that. When you click on add-ins, already whatever functions your Excel is having, that will be shown in the first, we can say, the portion of this dialog box. Okay. Then after that, in the last, you can see it here, manage Excel add-ins go. Just click on that go. The window will appear here, and it will have 4 options or 2 options, depend on what type of and what we can say as Microsoft Office you will be having. So it has already analysis tool pack. Just you need to tick on that one. It is unchecked. It may be unchecked there. Just you need to check that one. Okay, and click on OK. Then you will find in the ribbon in data one data analysis named dialog, or we can say the command will be there in your MS Excel. That will shown in the right top corner. Okay, here like this, data analysis. When you click on that, you will find that all type of analysis are available there, which has ANOVA, then correlation, then covariance, F-test, histogram, we can say regression, T-test, Z-test, everything is there. So this is how you can activate data analysis tool pack in your own Excel. I think it is clear to everyone.
Sir, can you please repeat again, sir? Once again.
Okay, yes. So go to Excel, open an Excel file, go to the left top corner, file, click on that. After clicking on that, you will find that the last item, that is option. Click on option. After clicking on option, then you will get the Excel options. In Excel options, the second last item, add-ins, you need to click. And after that, manage, the last item you can see there, manage here. Then Excel add-ins, then go. It will open this window. Click on analysis tool pack and then OK. Your analysis tool pack will be available in the data ribbon. We can say the ribbon which is appear on usually on our Excel. So data, and there the last item you can find in the right top corner will be data analysis. So it has all type of data statistical tests, we can say, already built in this thing, MS Excel.
So sorry for disturbance,
Yes.
but can you please tell the first option?
The first option, where, sir?
First means where to go.
You have to go to, you have first of all to open an Excel sheet. Okay.
I have opened.
Then go to file. In the left top corner, file will be there. Go there, click on that.
Yes.
Then you will find option in the last options.
Okay.
Yes, yes.
Click on that. Excel options, a dialog box will open to you.
Yes, sir.
Then in the command, you can see the second last command, add-ins.
Yes.
Click on that. Okay.
Then what to do, sir?
Then last, you can see in the last, manage Excel add-ins is already written there. Manage Excel add-ins. And then go.
Yes, yes.
Yes.
Okay,
Click the
got
button,
the
go.
point.
Click the button, go. And again, a dialog box will open. Just
Yes.
check analysis tool pack and then OK.
Yes.
Now you can find your data analysis tool pack in data. You can see there in the ribbon data. The last item is data analysis. Okay, this is the command, data analysis. I think you got.
Yeah, yes, sir. Thank you, sir.
Yes, thank you. Now, this is how we activated now the data analysis toolpack. Now you can work on this data analysis toolpack very easily. Now we'll be starting with our first point we have completed. Now second point we'll be going with. Second point is normality of the data. Dear friends, I believe that all of you are having knowledge about what is normality of the data, what is significance, effect, what is p-value. These are some statistics one must have to learn before starting any analysis, whether you want to do analysis in SPSS or SAS or R or MS Excel. Okay. Now for those statistical tests which are based on, like note my words, which are based on mean based tests. Mean, that means average based tests. A normality of the data is a must. That means if you wanted to go for ANOVA, if you wanted to go for T-test, if you wanted to go for regression analysis, that means all those tests where average is taken, then it is a must for a researcher to find out the normality of the data, whether our data is normal or not. What is a normality of the data means? That means the sample you have collected from the population possesses all the required attributes of the same population. Okay. Now, normality of the data, how it will be calculated? So for collection of the data, sample, we can say we used to circulate, or we used to forward our questionnaire by various means to our respondents. Respondents fill in their responses and then send it back to us. Either we do it manually, or we take the help of some, we can say, Google Forms like that one. Whatever data will be collected or which is manually we get is look like this one, this particular sheet. So this particular data will be working today is sent to me by one of my PhD student, Miss Tanisha. She has prepared a questionnaire for a study of how monetary and non-monetary factors effects on job performance, job satisfaction, and other things. So she has prepared this questionnaire on Google Forms and then send it to various organizations working pan-India. She has taken almost of 5 to 7 different organizations, and she has sent this questionnaire to the people working there in those organizations. And the data she got is again downloaded from Google Forms in this format of sheet. I think it is visible to everyone. Okay. So this data has some demographic questions like age, educational qualification, gender of the respondent, their marital status, family type, income group, and then some questions regarding their monetary and non-monetary, we can say, the emoluments they are receiving from their organizations. Similarly, this data again has the ranking, or we can say the scale given by the respondents for their ratings for organizational behavior or organizational working.
স্যার করে নেবো স্যার। আমি অ্যাকচুয়ালি আজকে দেখাচ্ছে স্যার ওই এক্সেলে কি করে ডাটা অ্যানালাইসিস করতে হয় ওটা ওটা ওটা
If you can please put off your mic, a request. So this is how this data has been. Dear friends, this data is a non-numeric data, and non-numeric data cannot be worked for statistics, or we can say statistical tests. So what we need to convert or code this data in numeric figures. I think you know that already. For your help, I can say, for example, this age is taken. So the age has been asked on, we can say, various parameters has been set for the age, starting from 20 to 30 years, and then 31 to 40 years, then 41 to 50 years, then from 51 and above, like that one. So there are 4 options given to the respondents, and the respondent will have to choose the required option. So what we can do here, we can convert 20 to 30 years of age with 1, 31 to 40 years of age with 2, 41 to 50 years of age with 3, 51 and above years of age is 4. Like that we can do. So we can now we can code the data, the non-numeric data, into numeric figures. Similarly, all this data regarding educational qualification, gender, marital status, family type, income, and the questions which were asked to respondents based on Likert scale, the whole questionnaire will be changed into numeric figures. Okay, so this whole data will be look like this sheet. This is nothing but the data which is already changed into numeric figures. I think it is understood to everyone here.
Yes, sir.
Any doubt to anybody? Yes, thank you. Now, further, whatever test you want to apply, whatever test you want to perform or analyze, will be done on this numeric data. Statistics is the whatever you wanted to perform, you need to perform through figures, numbers. The result will come out, the output will come out in numbers form. And by that we can interpret whatever the result says. Now, up till here we have converted our non-numeric data which we have received from our questionnaire into a numeric data. Now we'll perform the normality distribution tests. Now for that, what type of data will be needed? We need, actually our questionnaire has two types of questions. One is demographic questions and other is the response of the respondent on non-demographic questions. So for normality of the data, we need to focus only on, please see my words, we need to focus only and only on non-demographic data. So here what we need to do, we need to have a sum of non-demographic data row wise. How to do that? See, from this column F, we have the responses based upon non-demographic data. Responses based upon non-demographic data. So from column number F till the column number, what is there? Column number, the last question, column number O. These are the questions which were asked to the respondents based upon non-numeric data. Sorry, non-demographic data. So we need to have a sum of these questions row wise. How to do this? Put up equals to, just after when your question ends, put equals to, write sum, put open parenthesis, and then take F first, colon to F2O. Close the parenthesis, enter. Now your sum for first row has been here. 39. 39 is the sum of the responses you have got from first respondent regarding the question which is asked based on non-demographic data. Simply stretch it and you will get the sum of all the rows here. I think it is clear to everyone.
Yes, sir.
Yes. Now the next thing what you need to do is select this column, the sum column. Select this sum column. Whole sum column you need to select. Okay. And then Control C. Again, paste on this particular column with paste special. Click on paste special and then click on values. Click on values. Then OK. Why we have done this? Because we need to perform a very special function here. So what we have done? We have copied our sum column, paste it special, and clicked on values, and then enter. Then again, select this whole sum column, go to home, and then click on sort. Click on sort, smallest to largest, from small number to the large number, because we need to draw a bell-shaped curve, and bell-shaped curve starts from lower to higher and then comes to the lower end, like this one. So we need to have the smallest to largest function. We need to sort. It will ask for expand the selection. Okay with it. We'll click that. Now our whole data, the whole sum we have taken from smallest to largest. On this particular sum, we'll have to perform our next function, that is normality of the data. I think it is clear to everyone here. Okay. Any doubt to anybody?
No, sir, please continue.
Yes. We'll go to normality function. Now, this is what the sum of the data we have taken. Okay. This is our sum of the data. Okay. This is our sum. So for your help, like I have taken only a small section of this one. Now, how to perform this normality function? Okay. We delete a few of the things here. Yes. Then I will start with the things. Now, sum we have already taken. In the next column, you need to write z distribution of z distribution. Then next column, you need to write mean, and then the last one, standard deviation SD. Now we'll start with our mean. Formula for mean will be equals to average, A-V-E-R, A-G-E, average. You can see already average will appear here. Click on that and select your whole data. Close the parenthesis. You will have the mean of this whole data. In the similar way, we need to go for standard deviation equals to S-T-A-N-D-A-R-D, standard deviation. So ST you can write ST. So here when we write ST, it will give some options available here. This is a second option first option is standardized. Second option is standard deviation .p. .p that means for population. But what we have taken, we need to take standard deviation for sample. So we need to click on the third option. stdv.s, S for means for sample. So standard deviation for sample we need to take. Again, we'll select our whole data, close the parenthesis. Here, the standard deviation of the data is appeared. The last we'll do for z distribution equals to NORM, norm. So when you click on norm, that is normal distribution, click on the first one, normal dot distribution, click on that. It will ask for which data set you wanted to have this normality test. So first of all, it will ask about x. What is your x? So our x is our first number. This is x21. That is in cell J2. Then again, put a comma. It asks about mean. Where is your mean? Our mean stands in cell L2. Then again, put comma. It will ask about where is your standard deviation. So our standard deviation is in cell M2. So punch in M2. Again, comma. Then again, it will ask about cumulative. What does cumulative mean? Cumulative means that it has two things. One is true, another is false. When you place T, that is true, it has cumulative distribution function. It has cumulative distribution function. And false is known as probability mass function. So what type of, we can say, a function we need to have here? So we need to have here is true function, true. Okay, so true function, and then close it, enter that. So this is the value for your z. This is the value for your z. This z value has appeared here. Now again we can stretch this whole value to the other rows, but it will say there is some problem regarding this. Why? Because for x we have taken only first, this is z2 we have taken. We have to continue the same formula for our another rows. So for this particular thing we need to change a little bit in this formula. So formula is what? Our formula is
Excuse me,
norm
sir.
dot, yes.
Sorry to disturb you, but sir,
Yes.
your voice is not properly audible to me.
Okay. So is this the case with other participants, that my voice is cracking or breaking you?
No, sir.
No, sir.
Okay.
No, sir.
Okay.
Voice is
No, sir,
clear, I
not
think.
breaking, but there is a slow voice.
Okay.
Maybe you need to check from your end, ma'am, because it's clear from other end.
My end is also clear.
Ma'am, again rejoin, ma'am. Rejoin, ma'am. You can clear that.
Okay.
So shall we start here?
Yes, sir.
Yes.
Yes.
So we need to have a function which is known as absolute reference. What does absolute reference means? That means keeping mean and standard deviation fixed, keeping mean and standard deviation fixed for the data, but to change value of x every time. How do we do that? For that we need to press a function key which is known as a dollar function key, which is already there in your laptops, and we need to place a dollar sign before the value of, we can say, the where our L2, that is mean, is sitting. Okay, so we need to place a dollar sign before L, that is the column, and after the L column. Okay, like this one. Similar thing we have to do for our stunt division. We need to place a dollar sign before M and after M, like this one. Enter, and then when you click on that, your Z distribution is there for every row, that is for every X value. So I think up till here it is clear to everyone. Yes.
Sir.
Yes. Now, since our data is already in ascending order, we need to have our normal curve. So how to prepare that normal curve? Select both the columns sum and Z distribution. Select all the values, and then go to insert. Go to insert and then click on chart. You can see on chart there is a scatter chart. Okay, there is a scatter chart. So we need to click on that scatter chart like this. Okay.
સરસ છે આજનું સેશન.
Hello.
3-4 દિવસમાંનું આજનું સરસ.
I request the participants to mute themselves. Yes,
So,
sir, you can continue.
So here we can see a graph which is approaching like this one. The graph will be look like this one. See, I have taken only a small set of data. This is 54 item I have taken. So this is the reason only this half of the portion of the data is coming like this one. Okay. When you have the whole data set, a particular type of graph, we can say a bell-shaped graph will be look like. Okay, it will be appeared just like that one. Okay, when you select the whole of the data set in this way. So this will give you a picture for your proper bell-shaped curve, because only half of the data has been taken here. I think it is okay with everyone how to perform this function. Now we'll go for our next point, that is how to go for ANOVA single factor. Now, what is ANOVA single factor? Now, see, ANOVA single factor is when there is only one factor. We need to find out that whether that factor is having much of importance and existing everywhere in the field. So for that, I have taken again a set from the data. That is, there are 4 surveyors, and 4 surveyors were given a responsibility to have the consumer feedback of various sectors. So there are some 8-9 sectors where these 4 surveyors went and took the response of the consumers there regarding consumer behavior, okay, on the scale of 100, okay. And our hypothesis will be like this one. The survey method adopted by each surveyor is same. So alternate hypothesis will be, this is the null hypothesis. The first one is null hypothesis. The alternate hypothesis will be at least one of the surveyor has a different survey method. That means not all the surveyors are having the similar method, but any one of the surveyor, we don't know who, but that person, that surveyor is having a different approach for the survey. So we need to find out a test on that one. So we here will go for application of ANOVA single factor test. So how to do this ANOVA single factor test? So for that, we need to go to data, click on data analysis, and here we need to go for ANOVA single factor. Click on that ANOVA single factor. Command bar will open to you. It will ask first of all regarding the input range where your data is there. So our data, what we need to find out first of all, we need to find out whether there is a difference of approach of survey amongst the surveyors. Okay, that means our data is already there in the rows and column form. You can see it here. The column will have the surveyors, and the rows are the responses of the sectors on the basis of consumer behavior. So we need to find out whether there is a difference of approach of survey for the surveyors. So our data for surveyors is in column. Okay, if you wanted to have that there is a difference in consumer behavior, so our data will lie in the rows. Okay, so there are 2 types of data, one which is lying in the rows and another data which is lying in the columns. So here our hypothesis says difference in the surveyor's approach for survey, this lies in columns. So we need to have a test for columns, not for the rows. So just we need to click on ANOVA single factor. Our input range is here in the columns. We need to select all the columns. If your data set lies in rows, then we need to select what? We need to select then rows. How? This rows will be selected along with the sectors and other things. Okay. So we are not selecting the rows, but we are selecting the columns because we need to test the surveyors are having a unique or like method of survey. Then grouped by column, because we need to have a difference, whether there is a difference in survey method, that is in columns. Then labels, yes, we need a labels also for surveyors. We need a labels. Alpha values by default set at 0.05. So it will be by default. You can change it also. If your data is, so we can say perfect, you wanted to have, you can have it with 0.01% as well. Okay. Then output, we need our output where? We need our output somewhere here in this sheet also, or you can have your data output in some separate sheet. And then click on your survey result will appear here like this one. So your test will be like this. So surveyor 1, surveyor 2, surveyor 3, and surveyor 4, whether they are having a same approach or different approach, we can find it by the way of difference in the variance. See, the variance is differ for all the 4 surveys. For sure, there is a difference in the approach. Okay, it's not same. So our first table says about that all the 4 surveyors have at least not same, but a quite different way of surveying the consumers. This is our first table says. Now what our ANOVA table says. So this is the result for the ANOVA table. So ANOVA table says that our F value, that is ANOVA value, is 3.056. Whereas the alpha value, that is P value, says that it is 0.045. By default, our significant value was 0.05, and our P value, observed value of the P, is coming down there. उससे भी कम आ रही है, ठीक है? It is coming just like below 0.05. So what it says? It says that there is not the same approach for the surveyors for survey. There is a difference. This data says about. Now, how to report this data? This data will be reported in this way. If your F value is bigger than the F critical value, your F value is bigger than the F critical value, you can say it as that you reject the null hypothesis. We need to reject our null hypothesis. Similarly, we can do the whole thing with the way of P value. Here, our P value is below than that of 0.05 alpha level. So what does we can say? We can reject the null hypothesis. That means the method of survey adopted by all the 4 surveyors is different, not the same. So this is how we report. Now, how to write this result in APA form? So this result will be written in APA form in this manner. So we need to first of all write F. See it here. We need to write F value. F equals to this F value, that is 3.056 or 055. Okay, 3.056. Comma degree of freedom. Our degree of freedom is 3.28. This is comma P value. Our P value is 0.045. We can write 0.045. In the bracket, we need to write what was your alpha value. Our alpha value was 0.05. So our P value comes as below than that of 0.05. Hence, we reject null hypothesis. That is, surveyors are not having a like survey method. So this is how a single factor ANOVA will be worked. Now we'll go to follow another test, and which is known as a T-test. So for that, again, we are having a data here. Yes. So data is having, there are 2 teams. There are 2 teams of sales, and both were led by different managers. We can say the sales managers. And the data of the sales regarding 10 months starting from January to October was taken. And we need to compare which team has performed, or which team manager, sales manager, has performed well. By seeing the data, we can say it very easily. But my dear friends, we need to say the things in a scientific way after application of some tests. So here we'll apply T-test. Why T-test here? Previously we have applied ANOVA test because there were 4 surveyors. If your data is having more than of 2 cells or 2 columns or 2 rows, then we need to have ANOVA test. And if your data set is having only 2 columns or 2 rows, then we need to have less than 3 we can say, then we have to have t-test. So our hypothesis, null hypothesis will be the performance of the teams or performance of the managers are same, whereas the alternate hypothesis will be the performance of the teams is or not same. Now for this we need to report the t-test to sample assuming equal variance or unequal variance. What does it mean actually? When you have already calculated the variance and you find that the variance is equal, then you need to go for t-test assuming equal variance. And if you have not calculated variance on the data collected, then for sure you need to have simple t-test, to sample t-test with unequal variance. Here we have not calculated variance of both the teams or variance of the work done by both the managers. So we'll click on t-test with unequal variance. Now how to go about that particular thing? You need to go to data analysis, search for T. You can find it here, t-test. There are four options available. T-test paired to sample for means, then t-test to sample assuming equal variance, then t-test to sample for unequal variance. So here we have not calculated variance, so click on unequal variance. Now it will ask about where your data range is located. So our data range is located here in this first column. Our first column we have to select team 1 we have selected, or manager 1 we have selected, and again we click, and then it asks about variable second range. So we click on variable second range, that is team 2, and it will ask about hypothesized mean difference. So see, here we have taken the hypothesis, but we follow that our hypothesized mean difference is nothing. You can write it as 0 as well, but it is good that leave this particular column and let the system, we can say, work in background. And it will ask about the label. What do you need? The labels. Yes, we need the labels of both the teams. So we'll click on that one, labels. And then alpha value, by default it is set as 0.05. You can change it as well. And then it will ask about the output range. You can have your output in another sheet, or you can have your output somewhere here in this particular sheet as well. So we wanted to have our output here in this sheet only. So click on OK, and your output will appear like this one. So these are the result of two sample test. Now how to report, how to read this particular thing. So our result are like this one. The mean of both the teams is here. This is the mean of both the teams, 20.5 first team, 10.6 second team. The variance, you can see a very huge difference in the variance. And then number of observations, there were 10 observations. Hypothesized mean difference, by default it is 0. You can set it to any of the value if you have some. Then degree of freedom is 11. Then t statistics, our t statistics t value is 2.266, and t one tail is 0.02, whereas t two tail is 0.044. Both the values, whether it is one tail or two tail here, are below our 0.05 value. Okay, so because we wanted to have that the performance of the team are same or not same, we have framed our hypothesis in this way. So it is for sure that we have to take critical value of t for one tail. If our hypothesis would be like this one, that performance of team 1 is better than the team 2, then here we need to have or to follow the t-test critical value with two tail, not with one tail, because there we are sure that one team has performed well. So if your hypothesis is that one is performing better than the other or worse than the others, then it has to be taken, it has to be judged or interpreted on the basis of two-tailed test. Otherwise, if you are looking into this particular thing that both are same, both are equal, means are not means are same, means are equal, then you need to report your test on the basis of one tail test. Okay, so here we report that in APA style we usually report this one. So first of all, we conclude the thing. Your T statistics, if it is more than the T critical value, if your T statistics is more than the T critical value, then we'll reject the null hypothesis. So our T is 2.26 and the critical value of T for one tail is 1.7. Our T statistics is more than the T critical. So here we reject null hypothesis. Our hypothesis, null hypothesis was the performance of both the teams are same. But what test says is it is different. Now we can report the same by using p-value as well. Our p-value is 0.022, whereas our alpha value was set as 0.05. Here again, our P1 tail is below than that of 0.05. So we can conclude that we reject the null hypothesis, and now we need to report the same. The APA form we have to report this. So it is T equals to 1 point, T statistics equals to 1 point, not 1 point, but 2.266. Your degree of freedom is 10. Your P for one test, one tail is 0.02. Okay, and your P alpha was set at 0.05. So this is the way we need to write in APA style. And conclusion will be null hypothesis is failed to be accepted. That is, the performance of both the team is different. So this is how we report T with unequal variance. I think it is clear to everyone here. Any doubt? Yes. Now next is we have another test. Another test is ANOVA without replication. What does it mean actually? Without replication. See, if for in this case, like what the data we have collected from the respondents, we have data from different organizations, and the data so collected was not even on the basis of various demographies. That means the data based on the gender was unequal. That means not equal number of male and female were there. The data on the basis of the age again was not equal. We do not have the equal number of persons or respondents in the age. Okay, so here if you wanted to perform ANOVA function, then we need to have the same function by taking ANOVA without replication. Okay, if you have the data which is having an equal number of the sample, then ANOVA with replication will be applied there. That we'll see later. But here we need to find out that whether there is a difference in the incentives received and the job satisfaction of the people working in an organization on the basis of their income. Okay, on the basis of their income. So our null hypothesis will be like this one. So our null hypothesis will be there is no significant difference in mean value of incentives and job satisfaction in the selected organization. Okay, we need to find out that whether there is a difference in the incentives and the job satisfaction for the people who are working in different organizations. So this is our null hypothesis. There is no difference. Our null hypothesis is there is no difference. Now we need to find out that whether their difference is there or not. Okay, for that we need to perform a function which is known as ANOVA function. And for ANOVA function, we need to go for ANOVA without replication. So we'll do this by clicking on data analysis. go to ANOVA without replication, click on that. It will ask you about the input range. Where is our data lies? Our data lies here in this rows and columns. It has income, incentives, and job satisfaction. What do you want to have? We wanted to have that there is a difference. There is a difference, whether there is a difference, but we are saying there is no difference. So there is no difference with the incentives and the job satisfaction in the selected organization. So we'll select the whole data. We'll select the whole data and we'll put this whole data into this input range, and then we'll ask about labels. Do we need labels? Yes, definitely we need labels. By default, the alpha value is set as 0.05. As I told you earlier as well, you can change this alpha value based on your assumptions. And then the output range is it asked about. So our output lies, we want our output somewhere here in this sheet only, or you can have this output data in some another you can say Excel sheet. Click on OK, and your result will appear here. Okay, so what our result says, we have already worked on this one, so we'll look into that particular thing. What our result says, our result will display like this one. The summary of each row will be displayed. The summary of each row which says about the income, the count, sum, average, and variance. Okay, so generally this first sheet, where the first we can say the output of the sheet is only used with this last, we can say, the row. So here we can see incentives. So total 458 responses were taken, and the mean of the response was 3.89 for incentives. For job satisfaction, it was 3.41, and the variance was seen low in job satisfaction, whereas variance was seen high with the incentives. So this is how we report that there the variance in incentives and job satisfaction is differ, but it is not the result, the whole result. The whole picture will be displayed in this table, ANOVA table. Okay, now see what your result says. Your result says that this is the F value, the first one. This is your F value. This is the P value, alpha value, and this is F critical value for the rows and columns, both for rows and columns. So we can report now result as per rows and results as per column. Both we can report. So first of all, we'll report the results based on rows. What we have asked for? We have asked for people of wide income range, different vivid income range. They are receiving incentives working in different organizations, and they are receiving incentives, whether those incentives will boost their job satisfaction. Whatever they are receiving on different income level they are working, whether the incentives they are receiving induces or motivates towards their job satisfaction. So our null hypothesis were there is no significant difference for incentives and job satisfaction, and that will report by using the result which are shown in row column. Rows here. So our rows says that F value is 1.26, whereas F critical value is 1.16. See F critical value of F critical and F. Our F value, F calculated value is more than that of F critical value. So it says null hypothesis is rejected. Or we can report it on the basis of P value as well. Our P value observed is 0.005, whereas the alpha value was set as 0.05. Again, our P calculated is less than that of 0.05. What it says? It says null hypothesis is rejected, failed to be accepted. That means there is a difference in incentives and job satisfaction. Okay, there is a difference. The result says about this one. So how to report this one? We can report it by this way. There is no significant difference in the incentives and job satisfaction for employees of diverse income group. Of diverse income group. Sorry. Of diverse income group. Okay. So what does our result says? Our result says that the F value is 457 for degree of freedom. F D dot F dot F D dot F dot degree of freedom 457.49115. This is already reported here. See the degree of freedom. This is 457 and the total is 915. For 915 data, it is how much? It is 1.26. Our p value is lower than that of 0.05. Our p value is what? Our p value is 0.005, which is lower than that of 0.05. So what does it says? It says we reject null hypothesis. Okay, we reject null hypothesis here. And if we wanted to report the data based on the column, so the hypothesis will be there is no significant difference in the mean value of the incentives and job satisfaction in the selected organizations. Again, look at this one. What our data says in the column also. In the column also, our F calculated is 98.58, whereas the F critical is 3.86. If is more than that of critical value, again null hypothesis is rejected. That means different organizations are having different incentives plans, and different incentive plans leads to different job satisfaction levels. Not all organizations are having same incentive plans. This is the outcome. This is the interpretation we can have. The same we can report based on the p value. What is our p value is? Our p value is 3.62, but it has E-21. That means it starts with 0, then point, then 21 zeros afterwards. After the decimal, there are how many zeros? 21 zeros. And then come on the 22nd number is 3, then 24th 6, and 25th 2. So it will be 0.000000. How many zeros were there? 21 zeros will be there. So what does it mean? It means that our p value is less than that of 0.05. Hence, the hypothesis based on the column will say that if 1 degree of freedom 1 comma d dot f dot 1 comma 915 equals to 98.58. Here the p value is lower than that of 0.05. That is p equals to 0.0000. How many zeros you can write? You can write that. We reject null hypothesis. What does it mean again? That means there is a difference in the mean value of the incentives and the job satisfaction in the selected organization. Not all organizations having same incentive plans, and it again leads to different incentive plans, leads to different job satisfaction among the people working there in those organizations. This is how the result shows. Now we go to another test which is known as ANOVA with replication. Now what does replication mean? Here replication means that means if you have the equal set of responses. So here we have taken that two things, connect and recognition and organizational working condition. What does it mean actually? This is a we can say monetary performance, we can say the appraisal given to the respondents based on their ages. Okay. And then the organizational working condition, based on the organizational working condition. That means the more praises a person will receive, it will lead into more good in the organizational internal working system. So some questions were asked to the respondent on this basis, whether you are receiving praises, you are receiving some, we can say, the non-monetary benefits, some recognition in the job, and it will create an atmosphere of, we can say, a best of the working style there itself in the organization. So the data is collected on the basis of the age of the respondents. But here the point noted to be that all the data collected was equal. That means equal number of the people who are in the age group 20 to 30, equal number of the people who are of the age 31 to 40, then equal number of the people for the age 41 to 50, and equal number of the people for the age 51 and above was taken. And now we wanted to have, because this is equal number, so here we have to apply a test which is known as ANOVA with replication. So how to apply this test, we'll see it here. So go to data again, click on data analysis, click on ANOVA two-factor with replication, click on OK. It will ask you about the input range. Our input range lies where? Our input range lies here. So select age, connect recognition and organizational working condition. The whole data will be selected. Then it will ask about rows per sample. How many rows per sample are there? So I believe there are how many rows? So sorry. We'll need to calculate how many rows are there. So for particular sample 20 to 30, how many rows are there? We need to write. These are some 20 items. Each age group, 20 items were taken from each of the age group. Okay. Again, click on two-factor ANOVA with replication. Click on OK. Input range. Input range is age, connect recognition, and organizational working condition. Then OK. Rows per sample are 20. Alpha value by default it is set as 0.05. Your output will be, wants output where? We want output here, somewhere here. Okay, click on OK. Now your output will be reported. Now we'll look into output in this way. Already worked here by me. Now see. This is a summary. First of all, there are 3 tables. In fact, 4 tables are there for each of the age group. Okay. So variance of each of the age group, you can see the variance is for incentives in the job. The first one is incentives. It is variance is 0.61. For job satisfaction, it is 0.27 for age group 20 to 30. Whereas for 31 to 40, the incentives 0.95, for job satisfaction 0.23. For 51 and above, it is how much? It is 0.79, and for job satisfaction, or we can say the organizational working condition, is 1.6. That means from this table we can conclude that in these 3 tables we can conclude that people working in this particular age group 41 to 50 are getting more of the recognition and we can say the non-monetary benefits. And similarly, on this very basis, the motivation they feel in their job is having a higher variance as compared to the other age group people. This is what the reading of all the 4 age group data says. But this is not our whole result. Our result will lie here. Our result will lie here in this particular ANOVA table. So this says about sample, column, and interaction. So our thing which is of use will be for first, that is for sample, and another that will be for interaction. So we'll report our data by taking this sample, these three things, and with interaction, these three things. So first of all, we can see that the F value for sample is 5.85, whereas the critical value is 2.66. Again, you can find that our F calculated is lower than that of F critical. Okay, so that means there is an effect. There is no effect. The hypothesis will say there is no effect of recognition and praising on organizational working condition. But it says that there does a effect. There does the effect of connect and recognition on organizational working. That means if a team leader or the higher authorities praises the employee boosts up into the model and again ready to generate the output with more efficiency. Okay, so how to report this particular thing? So we report this by taking, yes, our hypothesis will be based on first recognition and organizational working condition. Recognition and organizational working conditions differ in organizations. So how to report this one? We report it as, so F3 T dot F dot F, that is F value for 3, 1. Now how we get this 3 and 1? See it here in the result once again. Yes. So this is 3, degree of freedom 3, and for 1. Like this one, we have to report for sample here, and for interaction, we'll report for 3 and 152. This we have to report for sample, and this we have to report for interaction. Okay, so our F is 5.85. We'll report this one. F degree of freedom 3, 1 is 5.85. Our p value is 0.05, which is lower than that of 0.05. That is 0.0008. So there is no difference. There is a difference in organizational working condition and recognition in the different organizations. Now for interaction effect, our hypothesis would be there is no interaction effect in the age working in different people working of different age in organizational sector for connect and recognition. That means overall impact will be seen in the form of interaction, and our interaction result will say about our F value is 4.02, which is lower than that of 2.66. So what does it say? It says that null hypothesis that there is no interaction effect is rejected. There is an interaction effect. There is effect of recognition and connect in the organization for organizational working condition. The result says like this one. So how to write in APA style? So it will be written as F 3, 152. That is 3 degree of freedom, 152 equals to 4.02. Our p value is 0.05, which is again lower than that of 0.000. It says that there is an interaction effect of the age, not gender, but the age. Okay, age of the different people working in different ages there, with different ages in organization, do have an interaction effect on the connect and recognition for organizational working condition. So this is how we report. And the last thing, in just 5 minutes, we'll see about that one. That is regression analysis. Okay. Now, how to go about this regression analysis is very, very easy. So for this particular thing, we have selected some of the respondents working in different organizations. Okay, some 14-15 people were selected. Okay, and those were asked to rate their team leader and the team performance. The team leader were asked to rate on the basis of 100 points, and team performance was asked to rate from 0 to 150 points. So different those 14 people rate their team leader and rate their team performance. Now what we need to find out here, whether there is, our hypothesis will be whether there is a linear relationship between team leadership and team performance. But our null hypothesis will be there is no linear relationship between leadership and performance, team leadership and team performance. Now, how to find out this? By the way of regression. So for that, we need to have this. We need to click on data again, then to click data analysis, then go for regression. Here we find it regression. Click on OK. It will ask about, first of all, the input range y. That means y and x. So see here, y is the resultant, the predictor. The predictor will be y. That means if there is a good leadership, the performance will increase. It is a common understanding that if there is a good leader, the performance will increase. So our y will be team performance. So first of all, we need to select team performance, that is y. Okay, and x range will be the intercept. Intercept, that means the independent variable. Or we can say like this one, y is the dependent variable and x is the independent variable. So here, independent variable is x, that is team leadership. Then we need labels. Yes, definitely we need labels. Leave other things. And then output range. Yes, we need our output here in this sheet only. We need our output where? We need our output somewhere here in this sheet only. Or we can have our output in other sheets. Then one important thing, that residual. Yes, we need residual we need. And one most important thing, that is line fit plot. These two things we need to click on OK, and your result will come. Your ANOVA, not ANOVA, the regression result will come. Okay, your summary output will come here. Now, how to report this one? See, first of all, your R value, that is correlation, is 0.88. What you have asked for? You asked for whether there is a linear relationship between leadership and performance. So this says that the relationship between performance and leadership is 88%. It is something really good. That means 88% performance depends on leadership, and if there is a positive relationship. Now the second thing, that is R square. R square is 78%, we can say 0.78, that is 78%. Almost it is 79. That means a change of 1%, or we can say a change of 100 in leadership will result into 78% change in performance. If there is a change of 100% in the leadership, the performance, that is the dependent variable, will change with 79%. It is something really good. That means if we wanted to have a regression equation, the regression model will be fit. How we can say a regression model will be fit? If your regression value is more than, see, if your regression value is more than R square value, we can say R square value is more than 0.65, let's say 65. It is better. If it is more than that, it is more better. Okay. If it is near to 1, it is something really good you have achieved. Okay. So these two things we need to report from here, that is value of R and value of R square. Now another thing which is we need to report, that is shown in this ANOVA. So our regression says our F value is 41 and the significance value of F, that is P value, we can say it is 4.92 and here is dash 0.5. That means after 0, 0.0, there are how many zeros? There are 5 zeros and then it starts with 4 and 9 and 2. That means again it says and it rejects our null hypothesis that there is no linear relationship between team leadership and team performance. What does it says? It says that there do have a relationship, linear relationship between team leadership and team performance. If there is a good team leader, the performance will be better. This is what our result says. So one important thing which this graph has, this output has taken is this particular graph. Okay, and say that there is a graph, I believe. Okay, yes, here is the graph. So team leadership line fit plot. This is of our importance. So we'll take this graph somewhere here so that it can be look good, it can be workable. We can take it here. Why it is not coming? Okay, let's see. We'll enlarge this one. Yes. So this is very important graph. Now we need to edit this graph somehow. So need to click on, first of all, OX axis. Click on OX axis. You can see that it starts with 0, but actual our data starts from somewhere between 30 to 20 to 40. So we can put it as the minimum is here is 0.00. We'll keep it as 30 on x-axis. Click on enter, and similar we have to go on OY axis. Our data here on OY axis starts with somewhere here with 80. So minimal 00 will cancel it and we'll have it 80. And then enter, yes. Now again, two things. You can see it here, a plus sign. Click on that plus sign and click on trend line. So it will ask about team performance. Yes, we need a line for team performance. Yes. So you can see it here that team, there is a line for linear, there is a linear relationship for team performance. Okay. Again, click on timeline. Then you can see an arrow which is approaching here. Click on that one. Go to more options and then click on predicted team performance. Yes, we need that also. Predicted team performance. Again, that will lie on predicted team performance is again lying on the same line, that is team performance. And then here only we have to click on display equation on the chart and then display R square on the chart. These two things we need to click and then enter. So here our regression equation is already available with the graph. Regression equation, that is y equals to bx plus a. What is y? Y is our predictor value. X is the change in the value every time with the change in we can say the rows available, and 58.226 is the intercept. And here R square is also shown. Now this is how we report our regression analysis with the help of regression output and the chart. So here I raise my voice. If you have any question, you can please ask.
Sir, there is a question, sir.
Yes,
In
ma'am.
that fit plot, fit plot part, you just double clicked on the chart and you got all the variations, na? How to
Yes.
Okay.
Yes. Just we need to, if you wanted to have a change on x-axis, just click on x-axis double. And if you want to change on y-axis, just click on y-axis double. So this dialog box will open on your right side, and accordingly you can have a changes.
Okay, sir.
Any more
Okay,
question?
sir.
Yes, thank
Sir,
you.
one more question, sir.
Yes.
I should not, it's an idiotic question, but I just wanted to ask, when you have created a table which was in the text format, the first part, I'm going to the first part of your first session, means the prior part,
Mhm.
where you have collected the information from your student about agree part and non-agreeing part.
This
First,
one.
yes, sir.
This one. Yes.
This one.
Hmm.
Sir, how did you converted this agree part? It is like nominally by doing yourself, or by making certain formulas using certain if conditions and putting it.
No, ma'am. It is very easy. Just
I'm
we
very
need
sorry,
to.
sir.
No, no, it's okay. It's okay. It's okay. See, research starts with such type of questions only. You should not be worried about this one. Okay. Even we all need to work. We all need to know about the things by asking this type of question only. Otherwise, where we can ask for? Okay. Yes. So it is very
Sir,
easy, ma'am. It is very
sir,
very easy. Just
sorry, but in SPSS we do give the variables, na?
yes,
Zero we can give male, or one, sorry,
yes.
one for male and zero
Yes.
for female, in that way.
Mhm.
But
Yes,
here,
yes.
how do you just
It is
show
very
me?
easy. It is very
Okay.
easy. See,
Okay.
I am taking what I am taking. I am taking this all Likert based question, na? All Likert based question. That is strongly
Yes, sir.
agree. This all question I have taken, which are here. Control C and place it all here in a
Okay.
phrase sheet. Okay.
Okay. Okay, sir.
Now see Control F. Control F and then strongly agree. Select Control C. Strongly agree. Place here. Find strongly agree. All strongly agree will be find in this particular
Oh my
sheet.
goodness, it's very
And
easy.
replace it with 5.
Oh my
Yes.
goodness. Okay, sir. Okay, sir.
It is already changed.
Okay,
Similar, we have
okay.
to go for other things. Copy again it and place in your data coded here. And
I'm very sorry,
like-
sir. I thought
no,
about
it's
it,
okay,
but
ma'am. And
thank you,
please
sir.
don't feel. Please don't feel.
Yeah, thank you,
Yes.
sir.
Yes.
Thank you.
Yes.
Thank you very much, sir.
Yes.
Thank you very much.
ma'am. Any more question? Yes. So I think that you have understand the basics of the data analysis tool pack, the use of all these things. See, my request to you all is just keep trying all these things. Time and again, you need to do take some, we can say some sheets, worksheets from download it from Google, and then start working on those data sheets. You can prepare your own data sheet where you are working in any college or wherever in your organization. Collect some small samples, some 20, 30, 50 samples collect with some 5-10 questions. Place all those questions in Excel sheet and then try to work on such, we can say, this analysis tool, like some various test, T-test, or we can say ANOVA test with replication, without replication, regression equation, all this thing. When you keep trying on all these things, now you will be master in these things. Okay, it is not a rocket science actually. Some 5-6 years back, I was working. I have attended one of the session of some person, like in one of the FDP, and there the person told us about that. Just keep trying your own work in your own ways. And I'm here presenting the same session with the intellects of the intellects and the people like you. It is nothing. It is not a rocket science actually. You can do that by your own. Just involve yourself. There may be mistakes, there may be faults, but keep trying. Surely you will do good one day. So thank you from my side.
Yes, sir.
Actually, I'm serious. Excuse me, sir.
Yes, ma'am.
Actually, sir, thank you so much, because I'm seriously thinking about that thing. How can I do this? This is very typical for me. Actually, it seems very scary for me. I'm a research scholar.
Yes.
So for me, it's a very initiate stage. So I'm very scary, and thank you for motivating me. Motivating us only, not on me, who is sitting over here.
But to put one word in that, the same thing where we have felt in these many days, na sir. You all guys, we should thank this RFI and their team to making our evening very beautiful with research minded. We have to thank them and you guys who are preparing this all stuff, na. You are making our evening very beautiful. Like there is a sunrise, but there is a beautiful end where there is a sunset. There is a beautiful day. We are ending that in a research point. We are very thankful, you guys, to you all.
Thank you, sir.
Yes.
Thank you, RFI. Actually, I'm a research scholar from Tripura University, but I was not aware of data analysis in Excel normally. We always use SPSS, that thing. But from today's class, I found that Excel is very easy for data analysis, and I'll be benefited from this
Yes.
class
Yes.
in further. Thank you, sir, for a nice session. It was
Thank
really an experiencing session for me. Thank you.
Yes. Yes.
Sir,
Thank you. Yes, ma'am.
Sir, can I take a help for all these tools? You have to use all these tools as basis and all.
Pardon, I'm not getting you, ma'am.